Welcome back. The objectives of this video are to explore rates of change in linear and quadratic functions, and we will also find the equation of a secant line. To rewind the clock a little bit, we've already talked about increasing and decreasing functions, and here we are with a quick review of those. Functions are increasing as if our x's increase from left to right and our y's are also increasing, then it's an increasing function. If our x's increase as we read from left to right and our y's are decreasing, it's a decreasing function. And here we have our concave up and concave down. A function is concave up if the rate of change is increasing. So we can see here the slope of our function here is becoming less and less negative and then more and more positive. It's concave up. And when it's concave down, it's becoming, what would that be? Less and less positive and then more and more negative. The rate of change is decreasing. And that is concave down. In example 6, let's consider the function f of x equals x squared minus 1. They ask us to complete the table for our y values over consecutive equal length input values, and those x intervals, the x's here, from -2 to -1 and -1 to 0 is a +1. So our average rate of change, if we want the change in y over change in x, we already know our denominator is a +1, so this is going to be not too bad. So every single one of these is going to be over 1. What do we notice about the average rates of change of f over consecutive equal lengths? So we need to find our y values here. So when we input -2 into our function, we get -2 squared, which is 4 minus 1. We get 3. And when we put -1 in, -1 quantity squared is 1 minus 1 is 0. We put 0 in, we get -1. We put 1 in for x, we get 0. We put 2 in for x, we get 4 minus 1 is 3. We put 3 and we get 8. So what's our average rate of change? Let's explore this. So from -2 to -1, we have an increase of, we have a decrease of 3. We go from 3 to 0. So that's -3. And then from 0 to -1, we have a decrease of -1. And from -1, and then from 0 to 1, we go from -1 to 0. So that's +1. From 1 to 2, we have an increase of 3. And from 2 to 3, we have an increase of 5. So our differences in each one of these, -3 to -1 to +1 to +3, each one of these has a change of +2 units. So our change in our rate of change is a constant. It's +2. And that answers our question. What do we notice about the average rates of change of f over consecutive equal length intervals? The average rate of change is constant in this quadratic function. It's equal to +2. So that means the average rate of change can be given by a linear function. Can be given by a linear function because our slope is 2. Our rate of change is constant. It's 2. In example 7, we're given a function, -x squared plus 4x plus 1. The graph of that is shown here at the right. It says find the average rate of change of g from -1 to 3. So when x is -1, y is -4. So that's the ordered pair -1, -4. And when x is 3, well, that was kind of handy. We have the ordered pair 3, 4. Well, we want the average rate of change on that. We could draw a secant line through there. And we want the slope of that line is what we want. Right? That's going to give us the average rate of change. Simply finding our slopes, we can do, what would that be? 4 minus a minus 4 all over 3 minus a minus 1. So our slope, our average rate of change, is equal to 8 over 4. It is equal to 2. Find the equation of the secant line containing the points for -1, g of -1, and 3, g of 3. Well, -1, g of -1 are the points that we just had. -1, -4 is -1, g of -1, and 3, 4 is 3, g of 3. So we have 2 points, and we actually have the slope of that line from the previous question. So once again, we will use point slope form to find the equation of this line. And it doesn't matter which point we can choose either one. Let's choose -1, -4. So y minus a minus 4, our slope is 2 times x minus a minus 1. So we get y plus 4 equals 2x plus 2. We subtract 4 from both sides, and we get y equals 2x minus 2. And that is the equation of this secant line. And it says sketch the secant line at the graph. I already did that, so now we can move on to example 8. Example 8, the average rate of change of h of x over the interval from 0 to 4 is 18. So our average rate of change from 0 to 4 is 18, which means that for every one value of x, our y changes 18. And we're changing 4 values of x. Some of you guys are going to go, well, that's just 18 times 4 is 72. So from 0 to 4, it's going to change 72. So you're going to go, well, 72 plus 2 is 74. That's great that we can do that mathematically. We're going to do this algebraically. And we're going to say h of 4 minus h of 0, which is our y, y2 minus y1, over our x's, 4 minus 0, is equal to 18. Our average rate of change is equals 18. So we put it into our equation. H of 4, we don't know what it is, but h of 0 is 2. So we can do h of 4 minus 2 over 4 equals 18. I'm going to multiply both sides by 4. There's our 18 times 4 that we had a few minutes ago. And we get h of 4 minus 2 equals 72. We add 2 to both sides. We get h of 4 equals 74. In example 9, suppose the demand for a product can be expressed given this quadratic function, where x is given in units of thousands. Find the average rate of change of demand when the number of items demanded increases from 2,000 to 4,000. So we are going to need P of 4, and we're going to need P of 2. So P of 4, we put that into our function. We get 0.2 times 4 squared plus 1.15 times 4 plus 5.4. I put that into my calculator and I get 13.2, and P of 2 is 0.2 times 2 squared plus 1 times 2 plus 5.4. I put that in my calculator and I get 8.5. So these are my y values. My outputs are 13.2 and 8.5. When my inputs are 4 and 2, I essentially have the ordered pairs for 13.2 thousand and 8.5, and I want to find the average rate of change. So 13.2 minus 8.5 all over 4 minus 2. Simplifies to 4.7 over 2, or 2.35. Then it says, find the average rate of change in demand when the number of items demanded increases from 1,000 to 5,000. And we're going to repeat the process. P of 5 minus P of 1 all over 5 minus 1 is going to be our average rate of change. So P of 5, I have to put 5 into my function for x. And when I do that, P of 5 is equal to 16.15, and P of 1 is equal to 6.75. So we have the ordered pairs 5, 16.15, and 1, 6.75. And we can do our slope equation. 16.15 minus 6.75 all over 5 minus 1 equals 9.4 over 4, which again is 2.35. We get the same answer. Coincidence? I think not. The average rate of change, as we may have discovered, in a quadratic function, is constant. It's that slope. So once we found it, that the slope of the average rate of change is 2.35 in A, we should have known the answer in B was also going to be 2.35. And we'll get some more practice with this when I see you in class.